All right. Good morning, good afternoon, good evening, or depending on your time and your location. I'm Engineer Moses Unafe. Previously, in our previous video, we discussed on classification of equipment into group category. Today, we are going to discuss on the topic hazardous area awareness with regards to gas group. Now, gas group play a critical role in grinding equipment selection to ensure operation efficiency, safety, and compliance with industrial standard. Their individual ensure that selected equipment along with project specification, environmental condition, and long-term maintenance strategies. Now, this gas group is classified into group 2A, 2B, and 2C. Gas are grouped based on how easily they can ignite. The lower the ignition energy, the more dangerous the gas is. And the higher the group classification, take for instance, group 2C is more hazardous than group 2B, respectively. Now, in grouping of this gas, 2A, ignition energy is high, meaning that it's harder to ignite. And if you talk about the explosion risk of this 2A, the explosion risk is what? Low risk. Example of it is propane, methane. Group 2B, the ignition energy is medium, while the risk is also what? Medium. And we talk about example of it is ethylene. Group 2C, the ignition energy is low, meaning that it's easier to ignite. And the risk involved is what? High risk. The example is hydrogen, acetylene, or a PMS vapor. This classification is part of an international standard and used to ensure safety in environment where flammable gas or vapor are present. I want you to understand that in practical example, some practical example like maybe installation of a flammable proof motor in a facility where we have hydrogen gas or a high PMS vapor. We have to consider or determine two factors. And the two factors that we need to determine is the ignition energy. What is this ignition energy? Is the energy needed to ignite the gas. Another factor that we need to consider is maximum experimental safeguard. And what is this maximum experimental safeguard? The maximum experimental safeguard is the widest gap between two metal surfaces that prevent an explosion from escaping and igniting a flammable atmosphere outside the explosion. It is critical safety measure used in designing a flame-proof exposure for electrical equipment in hazardous area. This determines the experimental by testing how easily the flame can pass through the narrow gap. And this flame can pass through that gap is considered as safe. So when you notice that this flame can never pass through that gap, that is to say that the explosive proof is what? Is safe to use in that what? Environment. So therefore, a maximum experimental safe gap is the value vary depending on the type of gas or vapor which are currently what? Present. And I also want us to consider the minimal ignition current, because in every explosive flame proof, there must be an electrical device inside, on site. So there is a need for us to consider the minimal ignition current. This minimal ignition current is the lowest electrical current that can ignite a specific gas, air mixture, under a controlled condition. It is the key parameters used in intrinsic safety, a protection technique that ensures electrical equipment would ignite flammable gas even in a faulty what? Condition. Minimal ignition current is experimental and determined and varies depending on one, the electrical circuit characteristics. The characteristics are the resistive, the inductive, the capacitors. And because these are present in designing any electrical installation on this particular area where we have hydrogen gas or a high PMS vapor, it is important to prioritize all these factors. There is a need for us to also determine the minimal ignition current. How do we determine it? We determine this by spark generation. This spark generation is a controlled spark produced using a resistive what? Circuit. And we can also determine this by the gas mixture. And this gas mixture is precisely a gas air mixture introduced into what? Test chamber. And we can determine this also by current variation. Current variation is gradually increasing until ignition what? Occur. This increase can due to what? Fault current as a result of surge or short circuit. And if you look at our table, just like as we rightly said here, you will see that in propane is in group 2A, and the maximum experimental safe gap is greater than what? 0.9. Why the minimum ignition current is 70 milliamps. And take, for instance, hydrogen, acetylene, or maybe PMS vapor. It is in group 2C. And that is to say that our maximum experimental safe gap should be less than 0.45. Or the minimal ignition current should also be what? 20 milliamps. So in designing any of these circuits that you want to use in this kind of environment where you have storage of hydrogen, acetylene, or higher PMS vapor, you should consider the minimum ignition current to be what? 21 milliamps. I want us to understand that in gas grouping, I want us to take note that the equipment sanctified for more scenarios of subdivision may be used in less what? Subdivision. Take, for instance, equipment sanctified to gas subdivision 2C or 2B and 2A gas subdivisions. This equipment sanctified to gas subdivision 2B may be used in 2B and 2A gas subdivision. What it means is that if equipment that is sanctified for use in an area of 2B can be used for 2B and what? 2A. So if an equipment is also sanctified for use or as gas subdivision of 2A may be used within 2A gas only. That is to say, in an environment where you have a storage of hydrogen or acetylene or higher PMS vapor. Note that equipment sanctified for more scenarios of subdivision may use in less scenarios subdivision. Now, equipment sanctified for gas subdivision like 2C, 2B, and 2A gas subdivision can also be used for a subdivision of what? 2B, and may be used for 2B and 2A gas subdivision. I want us to understand that in selection of installation, we should prioritize the zone, being zone 0, zone 1, and zone 2, so that we can be able to know the equipment subdivision that we might rightly fit into that particular zone, and also to consider the minimum ignition current and the maximum experimental safe gap of that equipment, meaning explosive proof. I want you to also share this video so that others can gain knowledge and watch out for the other section. Thank you.